RNN extensions long short-term memory LSTM. A gathering mechanism of the LSTM output gate. Output exposure. How much is CFT should be exposed. O of t sigma Q naught W naught H of t minus 1 x of t. OT equal to sigma of WO xt plus UO ht minus 1. These gates match the assessment recording parts of the memory CT. CT needs be exposed or present in the hidden state. HT means hidden state. Hidden state. RNN extension long short-term memory. Gathering mechanism of the LSTM, the hidden state. The hidden state. Hidden state what? OT TEF HG of CT. This one. OT. This one. These both are hidden state. So, conclusion on LSTM. LSTM contains information outside the normal flow of the recurrent network. In a gated cell. Information can be stored, written to, or read from a cell, much like data in a computer memory. The cells learn when to allow data to enter or leave before deleted through iterative process, making guesses, back propagating error, and adjusting weights via gradient descent. Why LSTM can compact the vanished gradient problem. LSTM help preserve the error can be back propagated through time and layers by maintaining a more constant error. They allow recurrent units to continue to learn over many time steps over thousand times, thereby operating a channel to link causes and effects remotely. What can RNN can do? Machine translation, visual question answering. Machine translation. What is the machine translation? The input is sequence of words of source language, and the output is a sequence of words targeted language. Encoder an RNN to encode the input sentence into a hidden state. Decoder an RNN with the hidden state of the sentence in source language as input and output the translated sentence. Encoder decoder architecture for machine translation. This is the enable code. This is the decoder. Encoder. This is the encoder. This is decoder. Demo website. We give a visual question answering. Given an image and a natural language question about the image. The task is to provide an accurate natural language answer. What is the mustard made of? A system. Bananas. Visual question answering. Visual question. Input image. Convolutional neural network. Convolutional neural network. Here, word embeddings. Input question is this person dancing. First connected pre-forward neural network. Output probabilities over the 1000 strong answer space. The output is to be conditioned on both image and the textual inputs. Here, CNN is used to encode the image and RNN is implemented to encode the sentence. Unsupervised learning. Autoencoders. Autoencoders. Deep autoencoders. Denoising autoencoders. Stick denoising autoencoders. 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 An autoencoder is feed-forward neural network that learns to predict input itself in the output. YFT. X power I. The input to hidden part corresponds to an encoder. The hidden to output part corresponds decoder. Decoder. This one connected to output, targeted output. This one layer 2, layer 3, HP, W of X. Deep auto encoders. Deep auto encoders. A deep auto encoder is constructed by extending the encoder, extending the encoder and decoder of autoencoder with multiple hidden layers. Gradient vanishing problem. The gradient becomes too small as passes back through many layers. Training deep auto encoders. That pre-training RVM, create of RVM, okay, encoder, decoder, fine tuning from here to there. weightage only changes, most probably. Denoising autoencoders. By adding stochastic noise to it can be forced autoencoder to learn more robust features. Adding stochastic noise to it can force autoencoder to learn more robust features. Denoising autoencoders. By adding stochastic noise to it can force autoencoder to learn more robust features. By adding stochastic noise to it can force autoencoder to learn more robust features. Training denoising autoencoders. The loss function of denoising autoencoder. Minimum W1, W2, B1, B2. The loss function X1, XL minus X cap L 22 plus lambda W1 mod of W1 F22 W plus F22, where H of L sigma W1 XL plus B1, here B2. Like deep autoencoder, we can state multiple denoising autoencoders layer wisely to form state denoising encoder autoencoder. Training denoising autoencoder on M1 IST. The following pictures show the difference between the resulting filters of denoising autoencoder trained on M1 IST with different noise ratios. No noise ratio 0, noise ratio 30%. Deep reinforcement learning. Reinforcement learning. Deep reinforcement learning. Deep reinforcement learning. Deep reinforcement learning. Application playing Atari games Alpha O. Reinforcement learning. Deep reinforcement learning applications player Atari games are Alpha O. Reinforcement learning. What is reinforcement learning? Observation, reward, environment, agent, actions. Agent interacts with the environment and learns by policies and the value function. Policy by is behavior function selecting actions given states A equal to pi of s. Value function q of pi SA is expected total reward or from state S and action and policy by q by of SA equal to E RT plus 1 plus omega gamma RT plus 2 comma RT plus 3 plus SAFA. S comma A. How good is action? Alpha in state S. Approaches to reinforcement learning. Policy based RL. Search directly for the optimal policy by policy achieving maximum future reward.